Hi everyone. In this video, we're going to talk about proportional and non-proportional relationship. Each set of values will give us a relationship that is proportional or non-proportional. So let's look at the first one. If it is proportional, then every time you divide y by x, you would get the same value we call constant ratio. And we use the letter K to represent that. So let's check and see what happens every time we divide y by x in this relationship. So 12 divided by 4, use a different color. 12 divided by 4 equals 3. 15 divided by 5 equals 3. 21 divided by 7 equals 3. So this relationship is proportional because we're constantly getting a constant ratio. In this case, it's 3. Every time we divide y by x, we end up with a constant ratio of 3. So the k value in this relationship here is 3. So k equals 3. To write the equation that goes with this relationship, we can use the equation of proportionality, which is y equals kx. And all we have to do is replace the k value with the constant ratio that goes with these set of values, and then we have our equation. So then our equation is going to be y equals 3 for k, and x is just x. And this is the equation that goes with this set of values. Okay, so let's see, how is this number changing from 5 to 7? We'll add 2. From 7 to 9, add 2. Okay, so the k value here is constant ratio. Because this is not proportional, what we're looking for is called the constant rate of change. And the constant rate of change is actually determined the way we determine the constant of ratio, y divided by x. So we'll have 6 divided by 2, and our constant rate is 3. Okay, so we're going to need that to write our equation. So we're going to say y equals 3x, okay, just like we did the first one here. We kind of use this equation right here, but we can't stop here, okay, because y equals 3x doesn't really represent this equation. Look, replace x with 5. 3 times 5 is 15, but our y value here says 16, okay? So we have to do something to this equation to make it work. So 3 times x plus what? 3 times 5 is 15. What do we have to add to get 16? 3 times 5 is 15, but we need to get 16. What should we add? If you said 1, that is correct. So we'll add 1. Okay, let's test and see if this equation is correct by checking to see if it works. So now let's replace x with 7. 3 times 7 is 21, plus 1 is 22. That works. But does it work with 9? Let's test that. 3 times 9 is 27. Add 1 is 28. It works here too. So that means this is the correct equation that goes with this relationship. Okay, let's look at the next one. You could look at it and you can tell this one is proportional because every time you divide y by x, you get a constant ratio. 10 divided by 2 is 5. 15 divided by 3 is 5. 20 divided by 4 is 5. So k value here is 5. We can simply write our equation y equals, remember it's y equals kx. All we have to do is replace k with 5 since the constant ratio or the value of k is 5. So that's the equation that goes with this relationship here, and it is proportional. Okay, let's keep going. All right, so 10 divided by 2, that's 5, but 14 divided by 3, that's not 5. So already we know it is not proportional. So we can still write the equation, we just have to do it differently. We're going to find a constant rate, which means you see how the y's are changing. From 10 to 14, you add 4. From 14 to 18, you add 4. And from 18 to 22, you add 4. And see how the x's are changing. Add 1, add 1, add 1. So y, change in y over change in x is going to give us our constant rate. So 4 divided by 1 gives us a constant rate of 4. Okay, so now we can write our equation. Y equals 4x. But we can't stop here because that's not really the equation. Let's check. 4, replace x with 2. 4 times 2 is 8, but we need to get 10. So what do I have to add to 8 to get 10? If you said 2, that is correct. Now let's check and see if it works every time. 4 times 3 is 12, and 12 plus 2 is 14. It works. Let's check the next one. 4 times 4 is 16, and 16 plus 2 is 18. It works. 4 times 5 is 20, and plus 2 is 22. Okay, let's look at the next one. Is this a proportional relationship? 50 divided by 2 gives me 25, and 75 divided by 3 gives me 25, and 100 divided by 4 gives me 25. So yes, this is a proportional relationship. And our constant ratio k is 25. So then our equation is going to be y equals 25x. Okay, let's go to the next one. All right, let's check and see if it's proportional. 5 divided by 1 is 5. 7 divided by 2 is not 5, so this is not proportional. So we're going to have to look for the constant rate. See how the y's are changing. From 5 to 7, we're adding 2. From 7 to 9, we're adding 2. From 9 to 11, we're adding 2. What about the x's? From 1 to 2, we're adding 1. From 2 to 3, add 1. And from 3 to 4, we're adding 1. Okay, so y, change in y over change in x is going to be 2 over 1, which is 2. Okay, so we can start by writing this equation. Y equals 2x, but we can't stop there because this is non-proportional. We're going to have to add or subtract something. Okay, let's see what we need. So let's replace x with 1. 2 times 1 is 2, but I need to get 5 for my y value. What should I add to 2 to get 5? Let's try that again. 2 times 1 is 2. What do I need to add to get 5? If you said 3, that is correct. But now let's check and see if this equation works for everything in this relationship here. 2 times, replace x with 2. 2 times 2 is 4, plus 3 does give me 7. So it works. Okay, x again. Replace x with 3. 2 times 3 is 6. And then add 3. That does give me 9. Okay, so it works. Let's do it one more time. 2 times 4 is 8. Plus 3 is 11. So this is our equation for this relationship. And it is not proportional. Okay, let's keep going. By quickly looking at this, you can see 9 divided by 3 is 3. 18 divided by 6 is 3. 9 divided by 27 is 3. So we can easily say the equation here is y equals 3x because it's a proportional relationship. And look, you can check 3 times 3 is 9. 3 times 6 is 18. And 3 times 9 is 27. All right, let's look at the next one. I can look at this one here and tell that it's not proportional because the numbers don't divide out evenly. So we're going to have to look for the constant rate. How is how is this number changing from 7 to 13? Plus 6, again plus 6, plus 6. What about these numbers? How are they changing? Plus 1, plus 1, plus 1. So then our change in y over x is 6 over 1. So then our equation is going to be y equals 6x. But that's not going to be enough because that's not proportional. So we have to add something or subtract something. But let's check, okay? So 6 times, let x be 1. 6 times 1 is 6. But what do I have to do? So my total is 7. What do I have to do? So if you said add 1, that is correct because 6 times 1 is 6 plus 1 is 7. Well, let's go ahead and try to replace x with 2. 6 times 2 is 12 plus 1. That does work. It's 13. Let's try the next one. 6 times 3 is 18 plus 1. It is 19. And the last one, 6 times 4 is 24 plus 1 is 25. So this relationship here, I'm going to write this one here, down here. Sorry, I don't want that color. Y equals 6x plus 1. So that works for this one right here. And now the last one. Okay, well, for negative 4 divided by 4 is 1. Negative 8 divided by 6. Okay, do you see that's not going to give us negative 1, so it's not proportional. So now let's just check. How are the values, the y values changing? Negative 4 to negative 8, that means we're subtracting 4. Subtract 4. And from negative 8 to negative 12, we're subtracting 4 again. Now let's see how this is changing. 4 to 6, we're adding 2. And 6 to 8, we're adding 2. So then change in y over change in x is negative 4 over 2, which is negative 2. Okay, so now we can start with this equation. Y equals negative 2x. But this is not proportional, so I've got to add or subtract something. But let's check. Okay, let's replace x with negative 4. So negative 4. Negative 2 times 4 is negative 8. But how do I end up with negative 4? Let's try that again. Negative 2 times 4 is negative 8. But I need to end up with negative 4. So what should I do? If you said add 4, that would be right. Okay, let's check it. Negative 2 times 4 is negative 8 plus 4 is negative 4. But does it work for the other two? Well, let's check. Negative 2 times 6 is negative 12 plus 4 is negative 8. So it does work here. Let's try it with this one here. Negative 2 times 8 is negative 16 plus 4 is negative 12. So it does work here. So this is the correct equation. Okay? And this concludes this lesson on determining if the relationship is proportional or not proportional and writing the equation that goes with the relationship.